So today I will continue this previous topic, that is analysis of LTI system. So the topic was this: analysis of LTI. LTI means linear time invariances. Okay, LTI systems. This is for discrete time only. Okay, but LTI system for analog continuous time. I think it will be discussed by Professor Sandeep Karmakar. Okay, so I am discussing about the discrete part only, discrete systems. Now, in our last class, we have shown that any arbitrary signal action can be given by this summation k xk delta n minus k. So it is a better summation of unit impulse function delta, and we can write in this form. Okay, so this is action. The summation will be over this index k. Now, my target is to find out the input-output relationship of our linear time invariant system, and at the same time, we have to define a particular function that is called actually impulse response of the system, and I will try to show that the response of any LTI system can be represented or can be expressed in terms of input signal and the impulse response of the system. Now let us first see what do we mean by impulse response. Okay, suppose I have a discrete time system which is LTI system. Okay, always try to remember that the impulse response will be defined for LTI system only here. Okay, so suppose this is LTI discrete time system, and here this is input side and this is output side. Okay, so if you apply some signal delta n unit impulse here at the input side of the linear time invariant discrete time system, then the output yn for this delta function at the input, that will be is equal to impulse response, and it will be written or it will be designated by Hn function. So this Hn is the output when you are applying some delta function at the input, and this Hn is called impulse response of the because it is response of the system when you are applying some impulse at the input side. So it is called impulse response of the LTI discrete time system. Okay. So this is our LTI system. Now, in most of the cases, actually, this agent for a particular LTI system will be given to you, and you have to find out the output of any arbitrary input signal. Okay, so Hn will be given to you, and that's why Hn will be defined first. So I am defining Hn first. Then if I apply some arbitrary input signal xt, then what about xn? Then what about the output yn in terms of Hn and xn? That is our duty to our work to find out that relationship between output, input, and this Hn. Okay, let us see what is the case. Here, yn is written as a transformation on delta n. Am I correct? Since the system is time invariant system, therefore, if the input becomes delta n minus k, then what should be the output? The output in that case for time invariant system, the output will be yn minus k.
Yes, sir.
Clear? Because this is LTI, this is a time invariant system. So when you are applying delta n minus k, then you will get yn minus k. This output is also shifted. An amount of shifting is equal to k. So you can write that yn minus k, that is the transformation on delta t. Delta n minus k. Okay. So if we take this idea, then suppose our input signal is, this is our signal where Hn is defined. Okay, Hn is defined. Now Hn is given. Hn is equal to transformation of on delta n. Okay, this is given. And here, if you apply some arbitrary function xn, then what about yn? Okay, this is the question. We have to answer this. Now you see, we have already defined xn is equal to summation k.
Sir, Hn is the function inside the LTI discrete time system. The function.
No. Hi is the system characteristic which is called impulse response. Means this impulse response will be given to you.
Okay, sir.
If you apply delta n at the input side of this discrete time system, then you are getting Hn. That Hn will be supplied to you.
Okay, so if xn is delta n, in that case we get Hn out.
No, when you are applying xn, which is arbitrary function, then what will be the output that we have to find out? What will be output in terms of Hn and xn?
Okay.
Hn is given. Hn is the output when you are applying delta n at the input. But if you apply xn, then what will be the output?
Okay, sir.
When you are applying delta n, then what will be the response that will be given to you? That means Hn will be given to you. Hn is the system impulse function that will be supplied. This Hn depends on the system parameters. Different parameters or different circuit components are used inside the system, and Hn is dependent on those system interconnection of the system. What is the type of interconnection or what are the system parameters? Based on that, this Hn will be decided. Okay. So Hn is supplied to you. If Hn is supplied to you, and for a particular system, Hn is supplied to you, and I will give you some arbitrary function xn. Then if I ask you what should be the Hn, what should be the yn, then you have to find out that. For that, you have to find out the relationship between Hn, yn and xn. I will prove that yn is equal to xn convolve Hn. I will discuss what is convolution. This is convolution. Xn convolution Hn. So xn is convolved with Hn, then you are getting yn. This is a convolution operation. Sometimes it is written in this form, convolution operation. I will discuss about this convolution operation just at the end of this class. Okay, what is convolution operation? Now let us see how we can achieve this. Now you know that xn is equal to xk delta n minus k. So yn is equal to transformation of xn is equal to transformation on summation k xk delta n minus k. So this equal to summation k xk transformation on delta n minus k. You may ask that why you are just using this transformation operator here but not here at before xn, before xk, because here you see I told you that yn is equal to transformation of xn. That means this transformation operation will be used on a function which will be a function of n. Then you are getting yn. Okay, but here x is the parameter, x is the dummy variable. So you will put some value here in place of k. K may be 1, then 1 sample delay. K may be 2. But ultimately, this function which is generated is a function of n. Therefore, the transformation operation will be used on that particular function where n variable is there. In xk, there is no n variable, but in delta n minus k, n is there. Therefore, the transformation operation is used on delta n minus k. Okay? So, now here from this part, what I can write, that is, so yn is equal to now summation k. Okay. In general, actually k is equal to 1 to infinity. This is taken. Okay. So I am writing k, then xk. Okay. And what is this transformation of delta n minus k? What is this? This is equal to hn minus k. I have already written. Okay, because we know that hn is equal to transformation of delta n, and hn minus k is equal to transformation of delta n minus k. Okay, so transformation of delta n minus k is equal to hn minus k. So here you can write hn minus k. Okay, so in general form, what I can write, if I take all the sample values, then yn is written as this xk h. So linearity, since we are using some summation sign, okay, and you are adding the outputs for all individual inputs, therefore it is linear. And since I have used the property of time invariancy here, so this is also time invariant. And since it is a linear and time invariant property, both properties are used for this particular system. That's why this system is called LTI system. So h n minus k and k is equal to 0 to in general form minus infinite to plus infinite. This is the relationship between input and output of a system. You see, for a system, linear time invariant system, hn will be given to you. If you know this hn and if you know this xn, then you know xn means you know xk. So just you perform this multiplication and this, then you add all these terms, then you will get the output yn. Okay. Now this yn, this summation is sometimes called convolution summation. So I will write that this equal to xn convolution h. Okay. Now I want to discuss this convolution in details. Okay. Just what is convolution? Let us see. Convolution.
So, sir,
yes.
Sir, yn is a convolution of xk and hn minus k, or
no, xn and hn.
Okay, sir. Okay, sir.
xn and hn. This. Okay. I think in continuous function you have studied this convolution operation, and there is a property in Laplace transform and also in Fourier transform, where if you take the Fourier transform of two convolved functions, then in frequency domain they will be multiplied. Okay, so I will discuss that part once again here for discrete time signal. Okay, now so next I want to discuss this convolution operation or convolution summation, here sometimes called convolution summation. or convolution summation or convolution summation. Okay. Suppose I have two discrete time signals x1t and x1n and x2n. I have two discrete time signals x1n and x2n. Now, convolution between these two discrete time signals or these two discrete sequences can be written as here x1n convolved x2n. Suppose this is your xn. So xn is the result of convolution of two signals, two discrete time signals x1n and x2n. And this is a symbol, but what type of mathematical operation is done for this convolution, that will be given in terms of summation. Now, this is equal to summation k is equal to minus infinite to plus infinite x1k x2n minus k. This is convolution. Okay. Or you can interchange this position. That means I want to say you can write this also. K is equal to minus infinite to plus infinite x2k x1n minus k. You can write this also. Okay. So what I want to say that if I have two signals, discrete time signals x1 and x1n and x2n, then x1n convolution x2n is equal to x2n convolution x1n. That means this convolution is always commutative. So if you interchange the position of the functions, then the result will be same. This is commutative. So convolution is commutative. Okay? Clear? Now let us see, if I take two signals, then how convolution operation is performed. I am giving one example, then it will be clear. Suppose x1n, this is a signal. Suppose this signal is 1, 1, 2, 1. And suppose I am giving the arrow sign here. And suppose x2n is another signal, that is equal to suppose 2, 2, 3. And this is the position of the arrow sign. Arrow sign means actually n is equal to 0 here. That means I want to say that x1 0 is equal to 1, x1 1 is equal to 2, and x1 2 is equal to 1. Similarly, x2 0 is equal to 2, x2 1 is equal to 2, and x2 3 is equal to 2 is equal to here 3. Okay. From these two signals we see. Now I want to say that here, suppose if you want to find out the convolution between these two signals, suppose xn is the convolution between these two signals, x1n convolution x2n, and this is nothing but a summation like this. x1k into x2n minus k. This is like this. K is equal to suppose minus infinite to plus infinite. Okay. And you see, actually, if n is less than 0, then signal value is not given. Means actually signal values are 0 for n less than 0. And for n greater than 2, again the signal values are not given. That means actually the signal values are 0. We will assume that. Okay. So based on that, I can perform this convolution operation. Suppose if you want to find out x0, then what about what is x0? X0 is equal to actually k is equal to minus infinite to plus infinite. Then x1 in place of x1 k, x2 0 minus k, because in place of n you have to write 0. In place of n you have to write 0. Okay. So this is equal to actually summation k is equal to minus infinite to plus infinite x1 k x2 minus k. Am I correct? Now, what is the value of this? Suppose k is equal to 0. K is equal to minus 1 means x of 1 and x1 of 1, x2 of minus 1. If you expand this, start from minus, let me write it from here, then it will be clear. Suppose I am giving the dot and I want to find out, I want to start from k is equal to minus 1, because for k less than minus 1 it will be always 0. I will tell you why it is 0. Suppose this is, if I start from k is equal to minus 1, then x1 will be minus 1 and x2 will be here 1. K is equal to minus 1 means this will be 1, minus k is there, and k is minus 1 means here minus 1. Now you see the value of x of minus 1, this will be 0 because x1 starts from 0, n is equal to 0. For n is equal to minus 1, x1 of minus 1 will be 0. The value is not given means actually it is 0. So this is 0, and whatever may be the value here, ultimately it will be 0. So this is for k is equal to minus 1. Then the summation starts from minus infinity. So here in the left hand side of this summation, all values will be automatically 0. Then when k is equal to 0, then x1 0 into x2 0. Then plus k is equal to 1, then x1 1 into x2 1. Then k is equal to, it is minus 1. Okay, plus, then k is equal to 2, x1 2, x2 minus 2. Now you see here x2 means argument of x2 is becoming negative from here, so it is 0. This term is 0, this term is 0. Again, other terms will also be 0. So we don't need to write this. So I can write plus dot dot dot. All terms will be 0. So this is 0. This value is 0, and other values are 0, and only one value is there to find out x0. So x0 is equal to, here what is the value of this, x10 into x20. x10 is equal to 1 and x20 is equal to 2. So the result is 2. So x0 is equal to 2. Okay, x0 is equal to 2. So you note it, x0 is equal to 2. You write it, x0 is equal to 2. Okay, then I have to find out x1. Okay, so if you want to find out x1, then what to do? Just this is the basic procedure. Then you can simplify this procedure. One simplest technique is there by which you can very easily find out the convolution result, convolution summation result. Suppose you want to find out x1, that means here in place of 0 you have to write 1. Then here also in place of 0 you have to write 1. So it is now 1 minus k. So this is now the summation. Okay, this is the summation. x1 is equal to this. Now x within bracket 1, this value how can we find out? Again you can start from k is equal to minus 2, then k is equal to minus 1. You can take k is equal to minus 3, minus 4 also, but you will see that for other values it will be 0. Starting from k is equal to minus 2. In the left hand side, in the negative side of k. In the positive side of k, Up to certain value of k, it will be positive, then it will be again negative. So how many terms I can get which will be non-zero, I can find out it here. Suppose you start from k is equal to -2. So when k is equal to -2, then it will be x12. So you just write 3 dots, then you write k is equal to 2. So x1 will be x12 into x2. 1 minus 2, that means -1. So it will be 0. If it is k is equal to 3, then in the left hand side k is equal to 3, then again it will be 0. And if you start from k is equal to -2, I am starting from -2 in the left hand side, then it will be -2, and it will be -2 means it will be 3. If you start from the left hand side -2, then if k is equal to -2, then it will be -2, then it will be -2 means it is 2, so 1 plus 2 means 3. Sorry, I have written here, it will be 3. Okay. So x1 minus 2 and x2 3, x1 minus 2, x2 3, this term will be generated for k is equal to -2, plus for k is equal to -1, x1 minus 1, this will be 0, and then x2 0, then plus k is equal to 0, x1 0, x2 1, k is equal to 1, x1 1, x2 0, k is equal to 2, x2 2, x1 2, x2 minus 1. Then other values will be 0. The -1 is started here. So next time will be x2. The x2 term will be x2 minus 2, that is 0. So other terms will be 0. Now from here you see this is 0. This is also 0 because minus term is there. Here minus term is there. But this is not 0. So it will, I have to keep it here. I have to keep this also. And again this is 0. And the next part will be 0. So here you see the simplest form is coming x1 0, x2 1 plus x1 1, x2 0. So now you know what is x1 0, x2 0. You take it from here. Okay, you take these values from here and you put, you will get what is the value of x1. Okay, so in this way you can get x1. For this case it will be, suppose x1 0 is equal to 1, then into x2 1 is equal to, x2 1 is equal to 2 plus x1 1 is equal to 2 into, then x2 0 is equal to 2. So this is equal to 2 plus 4. So this is 6. That means this result will be 6. Then you can find out x2. So you just perform the summation operation in this way. For different values of n, you can find out the values of the resulting signal. So what I want to say that you perform this summation operation, convolution summation operation, and you find out the value of x0, x1, sorry, this is x1, x1, x2, x3, x3, x4, x5, and you will see that after computing few values, it may be up to x5 or x6, the other values will be 0. Similarly, in the left hand side, you will see, if you try to compute x of -1 or x of -2 for this particular signal, they will be zeros. Okay, but for this particular signal, it is not for all signals. For this particular signals, x of -1, x of -2, or x of -3, all these values will be 0. For negative values of n, the values will be 0. And for positive values of n, starting from 0, you will get some values, for some values of positive n, you will get the values, non-zero values, then you will get the 0 values. For example, it may be that after n is equal to 5, for example, x6, the value may be 0. x7, the value may be 0, and rest part for all other values for all other values of n, xn will be 0s. So if you see that only this many values are there, just you write the result that these are the values. So this is the new sequence which is obtained after this convolution operation. Okay, so this is our convolution operation, and you can verify that if you interchange the position of the signals or functions, then it will give you same result. That means x1 n convolve x2 n will give you, that is equal to x2 n convolve x1 n. By interchanging the position of the signals, again you can try to find out the result of the convolution summation, and you will see they are giving the same sequence. Okay, because this is commutative. Now, therefore, so this is our convolution summation. Now, in case of a discrete time system, if Hn, that means impulse response, is given, this impulse response Hn it is always given in the form of sequence, because this is also a sequence. And if you are asked to find out the output of the system for a given unknown arbitrary signal xn, then this yn can be calculated by performing this equation, by performing this summation, convolution summation, by finding out the result of the convolution summation, k is equal to minus infinite to plus infinite, xk hn minus k, by using this, or hk xn minus k, because this is commutative, k is equal to minus infinite to plus infinite. If you perform this, here hn will be given, okay, it will be given, and xn will be given, okay, and you perform this convolution operation, you will get the result, get the output for the system. Clear? This is our the input-output relationship of linear for a linear time invariant system. Okay, in terms of the impulse response. Clear?
Yes, sir.
Now, here a system will be causal. Here I want to discuss about the causality of linear time invariant system and the stability of linear time invariant system. Causality of LTI system. For a LTI system, if you see that Hn is equal to 0 for n less than 0, then this is causal. Then, thus, if for a system the impulse response Hn is equal to 0 for n less than 0, then the system is called causal system. Otherwise, if you see that Hn not is equal to 0 for n less than 0, then it will be non-causal system. Okay, so this is the causality. What happened? Anyway,
I don't think you were
suppose this
audible,
is,
sir, for the last few seconds, sir.
huh?
I don't think you were audible for the last few seconds, sir.
Oh, I don't know why it is like that. It may be that someone may has
Oh, sir, you were not on mute, sir.
stopped.
You were not on mute. So I guess it was some internet
Now I
connection
am
problem,
not
sir.
mute.
No, no, no,
Now
no.
at this moment I am not mute. Okay.
No, sir.
Okay. So suppose I have a linear time invariant system for which the impulse response is given like this. In this sequence, the arrow sign is given here at the left hand side, the right hand side. Okay. Now you see, this is for n is equal to 0, this is for n is equal to -1, this is for n is equal to -2, this is for n is equal to -3, this is for n is equal to -4. That means h0 is equal to 0, h of -1 is equal to 1, h of -2 is equal to 2, h of -3 is equal to 3, and h of -4 is equal to 1. Now you see, here ha not is equal to 0 for n less than 0. Therefore, this system, whose impulse response is given in this form, that is a non-causal system. That is non-causal system. Okay. Or you can say anti-causal system also. And for a system, if Hn is given like this, 1, 3, 3, 2, and arrow sign is given here at the leftmost leftmost point, leftmost component. You are giving
Sir, in that case, causal, sir.
Then in that case, it is causal. Okay. So causality of LTI system can be determined by just observing the impulse response of the system. Clear? And then I want to discuss about the stability of the system. Stability of LTI system. Now you know what is stability condition. Okay, stability condition means actually if the input is bounded, means I want to discuss about BIBO stability. Bounded in, bounded out stability, BIBO stability. Input is bounded means actually xn should be xn should be less than mx, or sometimes it is given less than equal to and less than infinity, where mx is always a finite quantity, then input is bounded. So this is input bounded. I can write bounded input. For this bounded input, if the output is also bounded, that means output is also maintains this inequality condition. Okay, where my is another finite quantity, then I will say that output is also bounded. That means bounded output. And for a stable system, if bounded input produces bounded output in a system, then the system is called BIBO stable. You are applying bounded input at the input side and you are getting the bounded output at the output side. Then the system is called BIBO stable system. Okay, BIBO, bounded input, bounded output. Okay. Now, based on this criteria, I want to find out the stability criteria for the LTI system. For LTI system, actually, we know that Yn, this is equal to summation k is equal to minus infinite plus infinite xk h. I am writing here first hk. Okay. hk xn minus k. I can write this also, no problem. Okay. Now, what about Yn mod? This equal to mod summation k is equal to minus infinite to plus infinite hk xn minus k. Okay. Clear? So this is less than equal to, by using the theory of real numbers, I can write that this less than equal to k is equal to minus infinite to plus infinite mod hk into mod xn minus k. I can write this. Okay. Masi no kata janto chale na. Acha আমি ক্লাস আমি ক্লাসটা নিই বাড়ি নাও চুপ করে থাকো হ্যাঁ আমি ক্লাসটা নিচ্ছি now so what I can write that mod yn is less than equal to summation k is equal to minus infinite to plus infinite hk mod x n minus k. Now you see mod x n minus k for any value of k, this is always less than equal to mx. If you put bounded input to the system, if the system if the input is bounded, then this condition should be maintained, this less than infinity. Okay, input is bounded here. That means you can write that mod yn less than equal to summation k is equal to minus infinite to plus infinite mod hk into mx. Mx I am writing outside this. So mod hn is always less than equal to this. Now what is our necessary condition for the system to be stable? This mod yn should be less than equal to some my, which is finite. And this mod yn will be less than equal to some finite number if this summation is a finite, because mx is finite. You know, mx is finite, and if this is also finite, this summation infinite, this summation of infinite series is also finite, then automatically yn will be less than infinity, or it will be finite. Okay, now if I want to say that if k is equal to minus infinite to plus infinite mod hk is less than infinity, then yn mod will be less than infinity, less than equal to will be less than infinity. I am writing here less than infinity, or I may say that then mod n will be bounded or finite. It will be bounded or finite. Bounded means the value will be finite. If this infinite summation of this infinite sequence, hk may be infinite sequence also. It may be, it is not that hk is always finite sequence. It may be infinite sequence also. So if it is infinite sequence, then the summation of this sequence will be always finite. Then this is finite and that is also finite. So multiplication of two finite numbers will be finite. Then mod yn will be finite. And when mod yn is finite, then the system will be stable. Therefore, the condition of stability of a linear time invariant system is this. This should be always less than infinity. Okay. So based on this, our conclusion is this: if a linear time invariant system is given, then it indicates that hn is given. If we know the hn or impulse response of a linear time invariant system, then whether the system will be stable or not, that can be determined by finding out the summation of this series hk, k is equal to minus infinite to plus infinite, or mod. You find out this, or you can find out this n is equal to minus infinite to plus infinite. In place of k, you can write n also, no problem. You find this. If you see that this is less than infinity, then you say that the system which is characterized by this impulse response, that LTI system is stable. Okay. So an LTI system will be stable if the summation Hn mod Hn, n is equal to minus infinity to plus infinity. If this is less than infinity, then the system will be stable. So if Hn is given, you see the summation, you find out the summation. And if you see that the summation is finite, then you tell that the system is stable. If you see that the summation is infinite, then you say, please, the system is unstable. So I think all of you know how to find out the summation of a series. So you find out the summation of the system. For example, if I say that Hn is equal to 1 by n square for n greater than equal to, for n greater than 0, sorry, I am writing n greater than 0, or you can write n greater than equal to 1. Suppose a system, linear time invariant system is given for which Hn is equal to 1 by n square for n greater than equal to 0 and is equal to 0 for n less than equal to for n less than 1, for n less than 1. Then check whether the system is stable or not. Then what we have to do? You have to find out this summation n is equal to minus infinite to plus infinite Hn mod Hn. You find out the summation of this, and this will be actually, this will be equal to n is equal to here, because for n less than 1 it is 0, so you can write n is equal to 1 to infinity 1 by n square. You find out the summation. You can find out this summation. You check whether this series is converging or not. If the summation is finite, then the series will be converging, and if the series is converging, then automatically the system will be stable. Okay, and this is actually this is our infinite impulse response, because if you try to write this in the form of sequence, the first term will be 1, then second term will be 1 by 2 square, then third term will be 1 by 3 square, fourth term will be 1 by 4 square, and it will continue up to infinite. So how many elements are there for this Hn sequence? Infinite number of elements are there. Since in the impulse response of this particular system contains infinite number of elements, okay, infinite number of elements, therefore the system is called infinite impulse response system, or infinite impulse response in abbreviated form it is IIR system, infinite impulse response system. Okay, but sometimes Hn may be like this. Hn is equal to simply suppose 3, 3, 2, 1. Now you see only 4 elements are there, and 4 means actually number of elements is finite. Okay, therefore it is called finite impulse response. This type of system, a system which is characterized by this type of impulse response, where the number of elements in the sequence of the impulse response is finite, that is called that is called finite impulse response system. Finite impulse response, FIR system. Okay, now you see finite impulse response system is always stable, because you have finite number of elements, and if each element, in case of system actually each element of Hn will be finite, no element value will be infinite. Since all the elements are, the value of all the elements are finite, and number of elements is also finite, therefore the summation will be also finite, therefore the system will be always stable. So FIR system is always stable system, whereas IIR system may be stable, may be unstable. We have to determine by finding out this summation, infinite summation. If we see that the summation is finite, then I will say that this system is finite. Summation is finite means actually this is converging sequence. Then I will say that the system is stable system. Otherwise, if the result, summation result is infinite, then I will say that this is a diverging sequence. So the system is unstable system. Okay. So today we have learned what is LTI system. We have analyzed how we can find out the input-output relationship of LTI system by defining impulse response of the system. Then I have discussed about the convolution functions. What is the meaning of convolution functions? How we can calculate the convolution of two sequences. And then we have discussed about the finite impulse response systems. What is the definition of finite impulse response system? What is the definition of infinite impulse response system? And the stability and causality of linear time invariant system. And the conclusion is this, that finite impulse response system is always stable, whereas infinite impulse system may not be always stable. It may be always stable. It is not always stable. It depends on the summation of the series impulse response. Okay. So if you see that the summation is finite, then I will say that this is Vivo stable. If the summation is infinite, then I will say that this is Vivo unstable. Okay. So this is the gist of today's lecture. Thank you. Let me stop here. Again, actually in the next week, I think we have midterm examination, na? Hello?
Yes, sir. Yes, sir.
So on Friday, at this time, I will take your test.
Sir, will we get a subjective paper or subjective mixed
Objective,
paper?
all will be problems. Okay. All questions will be problems. Some problems will be objective and 2 or 3 will be subjective. Subjective
Okay,
means actually problem will be given. You have to solve. For multiple choice questions also, you have to solve it. You have to provide the solution.
Sir, will it be on
In
module,
one
sir?
sheet, you will write the answer, means only which is the answer, 1 or 2 or 3 or 4. Huh? So in one sheet, you will write the answers, and the solution, complete solution of those answers should be given in another sheet, and these 2 sheets will be actually combined in a PDF format, and you will send it to me. Okay.
Sir, one question, sir. Sir, one question, sir.
Yeah.
Sir, sir, for the objectives, you just have to write the answers.
No, you have to write the answer and the solution, complete solution also. Otherwise, it is very difficult for me to, check it. Whether a student has copied from someone or not, it is very difficult to identify that. Therefore, you have to give the complete solution also along with the answers.
And sir, the subjectives also we have to do it in the same paper as the objectives.
And for the subjective, means subjective is the problem. Again, subjective questions means is problem, numerical problem. But for that, 4 options will not be given. Okay, for objective questions, objective means multiple choice questions. 4 options, answer options will be given to you. You have to select the right answer or right option. But why are you choosing that right option? That should be solved. The solution should be provided in the answer. Okay.
And sir, is there any division, sir, for objective and subjective, sir, marks division?
15 marks, 25 marks, out of 25 marks, approximately 15 marks. It is not decided till now. Approximately 15 marks or 16 marks will be objective, then rest part will be subjective. It will be like that. It may vary, slight variation may be there.
Okay, sir. And on Friday, right? Scheduled plus time. Friday scheduled plus time. Okay, sir.
Friday from 3:45 I have a class, na?
Yes, sir. Sir, how much time will be getting, sir, for the exam, sir? Like
40 minutes.
Sir, it would be.
Can I give 1 hour? I can give 1 hour, but I don't know whether you have class or not.
So we don't have class, sir. So we don't have class after your
If you
class,
don't
right?
have class, then 3:45 to 4:45, I will give 1 hour.
Okay, sir. Thank you, sir.
Okay. Okay.